Hi everyone, as mentioned, weeks 4 and 5 will be an online recording. So this week for investments, we'll be going through week 4, which is going through CAPM, SIM for a single index model, and multi-factor models. So what I'd like all of you to do as well to make sure that you look at your textbooks and look at chapter 6.5 and 7.1 to 7.4. And this is pretty much the cornerstone of all investment theory, which is CAPM, standing for the capital asset pricing model, and single index model, also known as SIM, and multi-factor models. So for this week's class number 2, the laboratory, we'll be going through some textbook problems and also a single index model spreadsheet. And just a brief rundown on next week's lecture that will be on APT or asset arbitrage pricing theory and market efficiency. We won't be talking about the mid-semester, but I want you to have a look at chapter 7 and chapter 8 of your textbook and also behavioral biases because those are the theoretical underpinnings of the arbitrage pricing theory and market efficiency. And the lab will be largely going through just the textbook problems. Okay, so now before we get started, I'd like to talk about the separation property. Okay, so what is the separation property? It basically implies that portfolio choice, which means your choice of the best investment portfolio that you can have, can be fundamentally separate to two different tasks or two different jobs. Okay, so first of all, we need to determine the optimal risk-free portfolio. Now we know that we do that by creating efficient frontier, which is this yellow curved line over here, the P star. Right? So the efficient frontier consists of all of the different assets which are available on the stock market, right? And we actually create this curved line, which is in yellow. We also learned about indifference curves, right? So the indifference curves actually denote utility, where upon these purple lines, where the investor is indifferent to different sets of investment choices on that curve. So over here, we have three indifference curves, C1, C2, and C3. Now, ultimately, we also discussed before that if you actually are further up the line up here, means you're actually willing to take on more risk. So C1 is a more risk-averse investor than C3. Okay, so what actually happens is that you have a personal choice of the best mix of the risky portfolio and the risk-free asset. Now, the risky portfolio is the efficient frontier. So the efficient frontier is basically the most efficient risky portfolio. And we know the risk-free rate is basically the rate of return we get from investing in really safe assets like treasury bills or cash deposits. So we actually draw a line up over here, which is basically where this line starts at the risk-free rate and is at a tangent to the efficient frontier, and that becomes the capital asset line. So what happens over here is that depending on the investor's indifference curve or utility function, we can actually select a portfolio that suits him or her, in this case C1, C2, and C3, according to his level of risk aversion. So if you're more risk averse, you'll probably take an asset which is on the capital asset line, which is around here, which is a combination of the risk-free asset and the risky portfolio. So ultimately, the optimal portfolio of risky assets is independent of each investor's risk preference, but under specific assumptions, P star is the market portfolio, right? So the market portfolio is given by what's in yellow, which is the efficient frontier. All right. So what do we mean we talk the optimally complete portfolio? So think of it this way. In this case, you have a two-asset portfolio. One asset is the risk-free rate, and the other asset is the market portfolio. The market portfolio is given by this orange line, okay, and the risk-free asset sits over here, okay. So you can see over here, if this purple line is my indifference curve, or this is my utility function, if I don't have a risk-free asset, I'm so risk averse that I'm unable to actually invest into the market portfolio, because basically what happens over here is that the purple line and the yellow line don't intersect. So by actually including the risk-free asset, I can actually start to take an investment position, because my optimal portfolio becomes a combination of the risk-free asset and the market portfolio. So this line is called the capital asset line. So if I'm actually sitting here on the line, this actually means that my portfolio weight to the risk-free asset is 100%, and the weight that I have on the market portfolio is 0. However, as I move up the line up to here, this actually means I'm actually invested 100% in the market portfolio and 0% into the risk-free portfolio. So if I'm here just halfway in between the risk-free rate and the market portfolio, that means my portfolio weight is 50% into the risk-free asset and 50% to the market portfolio. Now, if I'm going above up to this section of the gray line, this actually means I'm actually borrowing money at the risk-free rate and actually investing more money into the portfolio. So essentially, if I'm actually traveling on this part of the gray line, I'm actually leveraging. I'm actually borrowing more money, okay, to actually invest more in the market portfolio, but I'm actually borrowing at the risk-free rate. So if you want to find the portfolio weights of C, the curve, what we actually use is this formula over here, YC equals the expected return on the portfolio minus the risk-free rate divided by A, which is the risk aversion, and this is the standard deviation of the portfolio, which is the risk, and 1 minus YC, where YC is over here. So remember, this is the y-axis, which is expected return on the portfolio, and this is standard deviation and or risk of the portfolio. So that pretty much describes the optimal complete portfolio. Basically consists of the risk-free rate and the market portfolio. And by having the risk-free rate incorporated into an investment strategy, we can basically satisfy any indifference curve, because basically if in this case the investor is actually more risk averse and there's no intersection, we can actually get him to invest more in the risk-free asset rather than the market portfolio.